All right, hey, organic chemistry. In order to gain back credit or earn full credit and review for our unit tests, you're going to have to watch these quiz corrections or how we're supposed to answer the quiz. So, if you had quiz 2A, you're going to be correcting and checking to make sure how we got the answers. So I wanted you to name the following compounds using IUPAC nomenclature. So in this first one, I have to find the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. It looks like 8 is my longest chain. I'm just going to circle it so you can see it. Here is 8. 8 is my longest chain. Okay? If 8's my longest chain, boom, octane. And a majority of you got octane. Then I have to look at these things that are attached, and I'm going to use a different color. I'm going to look at these things that are attached, and I have to name them and number them. Okay? So I have something here, something here, something here, something here, and something here. Okay, so I have 5 things that I have to name. Now, remember, you should number it left to right and right to left. 1, 2, 3, 4, 5, 6, 7, 8. And the other way, and I'll do that in a different color. I could do 1, 2, 3, 4, 5, 6, 7, 8. All right, so now your job is to figure out which numbers I have to use. Now, if I go from left to right, I end up having to do 3, 3 with the chlorine or the chloros, then 4, 4, 5, 6, 7 with the methyls. Okay? And if I go the other way, right? So on my third carbon, just to let you know, right? Because I didn't really show it. On my third carbon, I have a chlorine. I also have another chlorine, so 3, 3. You use more than one number if you have a substituent on the same carbon, right? So I could use 3 and 3, because that means I have 2 things on carbon number 3. And then 4, 4, 5, 6, 7. Now if I go the other way, I'll have 2, 3, 4, 5, 5, and then 6, 6. So the 2, 5, 5 will be those methyls, and the 6, 6 will be the chlorines. Now, I have to figure out which of these is my lowest sets of numbers. Now, if you can't do it by just looking at it, you have to add the numbers together. So 3 and 3 is 6, and 4 is 10, another 4 is 14, and 7 is 21. 6 and 6 is 12, plus another 5 is 17, plus another 5 is 22, 23, 24. So it looks like these are my numbers. I'm going to number it from left to right. So if I'm numbering it from left to right, I'll have 3, 3 dichloro, and then I have 4, 4, 7. Since there's 3 methyl groups, these are methyl groups. It'll be 4, 4, 7 trimethyl. And now I have to put these in alphabetical order. I already did it. Dichloro comes before methyl. Remember, the Greek prefixes do not count. So it's going to be 3, 3 dichloro, 4, 4, 7 trimethyl octane. Done. And then letter B here for number 1 is a lot of you did not do the right numbering, or a lot of you did not name these substituents. These are all the same type of substituents. This is methyl, and there's 4 of them. A lot of you said ethyl. Ethyl would look like this. This is ethyl. Or it would look like this. Okay, these are methyls, and there's 4 of them. And the way you number them is a way that numbers them that gives me my lowest set of numbers. If I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this will be 1, 1, 4, 4. But if I go the other way, if I do 1, 2, 3, 4, 5, I'm going to get 1, 3, 3, 1, 1, 3, 3. That's going to be a lower set of numbers. So the only way to number this is if I start with one of them being 1 and the other one being 3. Now, on my first carbon, I have 2 methyl groups. So it's going to be 1, 1. On my third carbon, I also have 2 methyl groups. So another 3, 3. All together, I have 4 methyls, which we call tetra. So 1133 tetramethyl. And then my parent here is a 5-membered ring, all single bonds, cyclopentane. 5 members for pent, all single bonds, ane, cyclo because it's a ring. Okay? All right, and then jumping on down to drawing from the name. All right, it says 2,2-dimethyl. Just so you know, di means I need 2 of these methyls, and methyl looks like this, or like this. These two are the same thing. This is what methyl looks like. A lot of you did this. A lot of you had that, or a lot of you did CH2, CH3. Make sure you know that methyl is just one line. 5-isopropyl. Isopropyl looks like this. Looks like a Y, or it'll be like C with a H, and then CH3, CH3. And you get these from your notes. And the parent name is heptane. Heptane is 7 carbons, all single bonds. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's my heptane, and I'm going to number it. I get to choose my numbering. 1, 2, 3, 4, 5, 6, 7. On the second carbon, which is 2, it says 2, 2. That means I am going to have 2 substituents on the second carbon, and the 2 substituents are methyl, dimethyl. So 2, 2-dimethyl. There you go. 2, 2-dimethyl means I have 2 methyl groups on the second carbon. And then 5-isopropyl. 3, 4, 5. Isopropyl looks like a Y. Done. And then lastly, it says 113355 hexamethyl cyclooctane. Hexa means 6, methyl means CH3 or something with a line. Cyclooctane is an 8-membered ring or 8-carbon ring, all single bonds, because it says ane, all single bonds. So if I want to draw an 8-carbon ring, that's like a stop sign. Looks like this. Almost there. Boom. 1, 2, 3, 4, 5, 6, 7, 8. And then I get to number it. 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter. 1, 1 means I have methyl groups, 2 of them, on the first carbon. 1, 1 means and this says hexamethyl. I'm going to have a total of 6 methyl groups. Hexamethyl means I have a total of 6 methyl groups, but I'm going to be able to put them all around my ring based off of the number. If it's 2 of the same number, they go on the same carbon. So 1, 1, 3, 3, and then 5, 5. Done. All right. So use this video and any notes I took, make sure you copied that. And then also for your correction, you need to tell me, you need to tell me what you did wrong. Tell me what you did wrong. All right, so I mentioned some things. So some of you had used the wrong substituents. Some of you didn't find the right parent name. Make sure you do that when you do your correction.